My name is Kunal Mehta, and I'm going to give you an intro to the SecureDrop Workstation. So I'm a senior software engineer at the Freedom of the Press Foundation. We're a US-based nonprofit organization. We train journalists to keep them and their sources safe. We advocate for press freedom rights, track press freedom violations in the US through the US Press Freedom Tracker, and most importantly, for today's talk, we build security-sensitive tools for journalists, including SecureDrop and Danger Zone. And if you want to find out more about FPF, there's our website URL right there. So what is SecureDrop? If you're not already familiar with it, it's a tool that lets sources and journalists communicate securely. It's used by media organizations and NGOs all around the world, and you can kind of see a picture of a number of organizations that do use it. It originally started in 2013 and has since expanded. And ultimately, at the end of the day, it prioritizes security and anonymity, which, while great, does cause some pain points. And if you've never seen SecureDrop in action, this is kind of an example of what it looks like. There's a group in Greece called Reporters United, and they have a project called Greek Leaks. And one of the things they advertise is to use SecureDrop. And they give a quick explanation of how it is and some of the other organizations that use it. So before we get into the SecureDrop workstation, let's talk about how SecureDrop worked previously. So first, journalists download encrypted submissions onto onto a laptop, and that's like the left side of the diagram titled JWS. From there, journalists move those submissions onto an air-gapped computer with a secret decryption key. This computer is kept offline, so the key is never accessible to the internet. And then finally, the files, once they're decrypted, are only opened on their offline computer, which prevents malware and from spreading and escaping. So let's talk about like what malware, especially malware that targets journalists, wants to do. Typically, whenever you open or execute a malicious file, that's when malware can run. There are two main things. One, it'll try to gain persistence. So that way it can run in the future without any interaction on your part. And second, it like tries to find data on your computer and then it exfiltrates it or sends it back to the author. In this case, using the air-gapped computer, because it's offline, it can't exfiltrate anything. Additionally, there's pretty limited opportunities for it to gain persistence because of how the air-gapped computer is set up. But we looked at it and thought, is there a better way? The classic method is pretty labor intensive, having to copy over and manually decrypt every single submission that you receive. And on the other hand, virtualization technology has greatly advanced since the project was started in 2013. So the SecureDrop team started a pilot project to explore using QubesOS for this purpose. And as you can see on the right, we published a blog post saying that we were starting a pilot project right at the end of February 2020. And as I'm sure everyone knows, March 2020 was a fantastic time to launch a brand new project. No one was occupied with absolutely anything else in the world. So what is QubesOS? It's an operating system like Mac, Windows, or Linux, but it's a security-focused one, and security through compartmentalization. And the basic concept is that it allows you to have multiple computers in one computer, and they're just called virtual machines. And so each virtual machine is effectively a separate computer, but you can interact with them all at the same time. And the use of virtual machines allows a few different nice capabilities, such as like you can disable internet access in specific virtual machines, or you could say like, oh, this virtual machine only connects over the Tor network. And you can also have burner VMs, which are for security. So every time you finish using it, it automatically resets to prevent any malware from gaining persistence. And there I've included a quote from Edward Snowden describing QubesOS as the best available OS for security and what he used, at least at the time he tweeted that. So like this is a screenshot from QubesOS, and you can see that there are three different windows in the screen, and each one has a different color menu bar, and that basically means they're in separate virtual machines, which is if they're in separate computers. So there's one virtual machine, which is the blue one used for typing in a document. There's another virtual machine being used to look at a picture of a dog. And finally, there's one in the background looking at the webcomic XKCD. And crucially, all three of those virtual machines don't know anything about the other three virtual machines. Um, so now let's talk about SecureDrop Workstation. We kind of discussed very briefly what QubesOS can do. So let's combine all of those features to build a workstation for accessing SecureDrop submissions. And because we can run effectively multiple computers inside the workstation, we split up the process into multiple components. There's a client, a decryption step, a viewer, and an export step. So going back to our original diagram, we can take the first part of the diagram is in the client computer. It downloads new submissions for journalists to review, and it's pretty similar to like an email inbox or chat application. Then the next step is the decryption. The decryption key is stored in an offline virtual machine, and because it's offline, it makes exfiltration harder. The next part is the viewer application. We use a burner VM to view files, so it prevents any malware from gaining persistence, and it's still offline, so exfiltration is even harder. And then finally, there's an export VM, which allows you to print documents or export them to encrypted USB. But that's enough of me talking. Let's actually see the system in action. So this is what it looks like when you boot up SecureDrop Workstation. Now, normally, as soon as you open it, it'll prompt you to install updates, but I installed updates ahead of time, so we can just directly log in now. So as I'm logging in, this login happens over a Tor hidden service. So it makes it much harder for anyone, even if they had login credential, to log in. And so right now that I've logged in, you can see that it kind of looks like an email inbox, and it's downloading new messages that have come in since. So when we like open a message, we can read the text. It's already been decrypted for us automatically. We don't have to do it manually anymore. And then we can if they sent a file, we can download it. And then when we click on a file, it'll open, and this process takes a few seconds. But you can see in the right corner that it's saying it's starting a new virtual machine, and here we are. This is the document. It's it's a leak from the Vulkan files that was released, I think leaked about 2 years ago out of Russia. And if you look at the top bar where the little mouse pointer is, you can see it says disp, and then there are 4 numbers. That means this is open in a disposable or a burner VM. And crucially, this is a different virtual machine than the one that the client application is in. So this file cannot access the internet, and it cannot access the actual client application, even if it was somehow malicious. Now let's open a second document, because I believe the source sent 2 documents. And so a new virtual machine is starting. And so that's the other part, is that each document is opened in a separate virtual machine. So even if the 2 documents were malicious together, they cannot coordinate or attack together. They're entirely isolated from each other. And so what I mentioned earlier is that like this whole process is these VMs are offline. So here I've opened a terminal, and I'm trying to make a request out to securedrop.org. And it says could not resolve host, which means that there's no internet access in the VM. So even if you manage to gain some type of code execution or execute malware, you would still not be able to send any data that you obtain over across the internet. Um, so now let's close those and let's try exporting. And so there are a few different options. You can print to export, and then you can just export to an encrypted USB. Printing is nice because for nearly every file, that is the one foolproof way to disarm it of any malware because it's just a piece of paper. Um, so, I talked about cubes being, virtual machines. And if we look in the top right, you can see the list of all the virtual machines that are currently running on the system. And you see the top two are the separate burner VMs titled disk. And then there are like, close to 10 different virtual machines that are just supporting the whole system. So now we can close the files that we opened earlier. And if you notice in the top right, it's saying that the virtual machines have immediately shut down. And that's part of what being a burner VM is. As soon as we close the file, the VM was deleted and will be reset. So that way, any attempt at persistence will entirely fail. The last step of using the workstation is cleanup. And so once a source has sent you messages, you don't want to hold on to them for too long, so you can delete messages. And there are two options. First, you can just delete the files and messages, which allows the source to, in this case, the source can continue to reply to you. Um, but there's another option, which is a full delete. And in this case, the source can no longer apply, but they can easily just create a new source account if they want to. So that was just a very, very quick demo of the SecureDrop Workstation. So now that we've built this and I've showed it off, I want to discuss who this project is for. Um, Primarily, it's concerned for journalists who are first concerned about their own security. SecureDrop Workstation aims to take all the measures possible to protect journalists. Um, Second, because it's concerned about your security, since those potential sources about 30, um, you know, um, malware targeting journalists is on the rise, and so this is a great way to at least take a big step to stopping it. Ultimately, like using the workstation means that you have to set up SecureDrop to receive tips, and that takes effort. And we know that it's currently not necessarily a thing that everyone can do, but we're actively working on trying to make setting it up easier. And then finally, like an important disclaimer is that no software can ever guarantee 100% security, and we certainly don't promise that. But we aim to be a best-in-class project. We perform regular security audits. We use depth in defense measures, and ultimately, we just take security very seriously. Um, so what's next? The SecureDrop Workstation just recently left a pilot phase, and we're currently getting more newsrooms that already use SecureDrop to adopt it. The development team, including myself, are continuing working on building features that were requested by journalists, and we're also refining the user experience. And then, in the future, we'd like to have integration with other projects like Signal and Danger Zone. Instead of just encrypting to USB, it would be nice if you could send, a file over Signal or something along this line. So if you want more information, the main workstation documentation is workstation.securedrop.org. If you want help or have any questions, securedrop.org/help. There's my contact information there. Signal is the best and most secure way to reach me, but I also have my email address. If you're interested, you can follow us on Mastodon and Blue Sky. And finally, if you're able, we are a US-based nonprofit, so you're welcome to donate, but no such obligation.